In this video, I'm going to talk about routine and non-routine problems involving division of whole numbers. So let's start with a routine problem. So here's an example of a routine problem. And by the way, routine problems are problems that can be solved with a fixed solution. That means you can just directly find a solution of the problem with using the basic skills that you have learned in your maths. And then not all routine problems are easy to solve. It even if there is a fixed solution, but sometimes it takes multiple steps before you can get the answer. But at least you are directed with what should be the solution, the expected solution to get the answer. So let's try to solve this. We have 5,876 pesos are distributed equally among 26 men. How much money will each person get? So let us solve this. Obviously, this is dividing the money to the 26 men. So we're gonna divide. So 5,876 divided by 26. And so we're gonna divide 5 by 26. So we're gonna use the two digits. 58 divide 26. It will be 2 because 2 times 26 is 52. And then subtract 58 minus 52, so it will be 6, and then bring down 7. So divide 67 by 26, it will be still 2 because if you choose 3 times 26, it will be 78, which is more than 67. So we'll just keep on, we'll just remain to 2. 2 times 26 is 52, and subtract, so it will be 15. Then bring down 6, so 156 divided by 26 will be 6, so which is exactly the same. So if you subtract, it will be 0. So that means the answer is 226 pesos. Now let's have another routine problem. So we have if 4,275 kilograms of rice is packed in 95 sacks, how much rice will each sack contain? And so we are going to divide this 4,275 to each of these sacks. There are 95 in all. So let's solve. So 4,275 divided by 95. So let's divide 4,275. So if you're gonna use 4, obviously it cannot be divided by 95, so we'll use two digits. So 42 divided by 95, still it is not possible to divide because 42 is smaller than 95. And so we're gonna use three digits, 4, 2, and 7. So 427 divided by 95. So of course you're gonna do some guess and check or trial and error until you get the closest number, the closest product to 427, that it will not exceed 427. And so we'll have 4 because 4 times 95 is 380, and that's the closest to 427. Then subtract, and so you will get 47. So 7 minus 0 is 7, and 4 borrow 4, it becomes 12 minus 8, so 4. So bring down 5. 475 divided by 95 is 5 because 5 times 95 is exactly 475. Then subtract, so this is 0. So that means uh, dividing the 4,275 kilos of rice into 95 sacks, so each sack will have 45 kilos of rice. So now let's move on to non-routine problem. So non-routine problems are different from routine problems because this cannot be solved in a fixed way. There is no fixed solution that can be taught in the classroom where you just simply follow whatever the teacher is doing, because in this problem there are so many possible ways to solve it, but it's even hard to find one. So non-routine problems are really hard. That's why they are called non-routine. So let's have this uh, problem. When the egg in a basket is grouped into 2, 3, or 5, there is always one extra. What is the least number of eggs for this grouping to be done? So in this problem, it is saying that there are a number of eggs given, but if you divide it by 2, by 3, by 4, by 5, you will have a remainder 1. So that makes it hard because the given is not the supposed to be given is not given, which is the number of eggs, and we're gonna find that. Alright, so let us solve this. So this is how I solve it. So I just multiply 2, 3, and 5. The reason why I multiply this is to make sure that the number that I will put is divisible by 2, 3, and 5, which is 2 times 3 is 6 times 5, 30. So 30 is divisible by 2, by 3, and by 5. That means it can be grouped. The 30 can be grouped by these 3. Now it is given that there is one extra for if it's grouped by 2, 3, or 5. And so I'm gonna add 1 so that there is always a remainder when 30 is divided by either of these 3 numbers. So 30 plus 1 is 31. That means there are 31 eggs. Now let's have another non-routine problem. So we have this a bit longer. A barangay official received some packs of relief goods to be distributed to COVID-19 affected areas. He planned to distribute it by group. If the packs were grouped into 3, 6, or 7, there is always an extra 2. What is the least possible number of packs given? So let us try to solve it in the same manner because it is similar to the previous non-routine problem. So now let us solve it, but it's a bit different because unlike the previous one, 2, 3, and 5 are not multiples of each other, while 3, 6, and 7 we have 3 and 6, where 6 is a multiple of 3. And so we're going to do it this way. So we're going to break it into prime factors 3 times 1. So because 3 is a prime number, so just leave it as 3 times 1. While 6 is a composite number, so it can be written as 3 times 2. So it's composed of primes. And then 7 is prime number, so just simply 7 times 1. So why are we doing this? It's to avoid multiplying the number twice. Just like if you multiply 3 times 6 times 7, then it's the same as you are multiplying the 3 twice because 6 contains 3. So to avoid that, we're going to break it into prime numbers, and then we're gonna find the numbers the numbers involved. So what are the prime numbers involved here? Are 3, 1, 2, and 7, and that's the only numbers that you're gonna multiply. But you don't need to include 1 because any number multiplied by 1 is just itself. So through this, you avoid multiplying the 3 twice. So that's the purpose of that. The reason why you do that so that you will get the least possible number, the least number that is divisible by 3, 6, and 7. Okay, so let us multiply this. 3 times 2 is 6, 6 times 7 is 42. So this is the least number that is divisible by the 3 numbers. And then it's given that there is, if the packs are grouped by 3, 6, or 7, there's always an extra 2. So we will add 2. so that there's always a remainder too whenever you divide 42 by 3, 6, and 7. So all in all, it will be 44 packs. Now I have another non-routine problem. So here it is. One brought some money to buy food from a bake shop. There are cookies that cost 7 pesos each, pandesal that cost 2 pesos each, and monai that cost 5 pesos each. If he will only choose one type of baked food, then buying cookies will leave him 5 pesos extra. Buying pandesal will leave him no change, and buying monai will leave him 4 pesos extra. How much money did Juan bring? So this is gonna be a harder problem compared to the previous two non-routine problems because um, the remainder is different for each amount, unlike the previous one that they have the same remainder, which is 2 and 1. Now here it's remainder 5, remainder 0, remainder 4. And how are we going to find the amount or the value that one brought? So by the way, you know let's talk about the products. Of course, you know the cookies for the pandesal and the monai. These are common in the Philippines. Pandesal is just a bread of salt, and the monai, which is also called the pandimongha, the bread of nuns. So these two are very common, and I am using um, the amount that is really the same with what is the real amount for these two uh, breads. So I will just leave this problem hanging, and so that you will have enough time to think about it, and please put your answer in the comment section if you have, so that I can check if you are having the right answer. So good luck and have fun. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.